All right, here's another example where we're going to find the local max and local min of a function utilizing our increasing decreasing test and our first derivative test. So here's the function. It's defined over this particular interval. And so step one, we need those critical numbers. That's why we spent so much time on that in the first section. So we need critical numbers, and we're going to go ahead and figure out those values for our derivatives. So our first derivative is going to be 1 plus 2 cosine x. So this is going to be 0 when 0 equals this. Obviously, there are no places where this is undefined. So 2 cosine x has to equal -1, so cosine is going to be -1/2. So where is the cosine -1/2? That's going to be in the second and fourth quadrants, if you're thinking of it like that. And it's the shorter distance, so it's going to be those, those pi over 3s, right? So you have 4 pi over 6, so 2 pi over 3, 2 pi over 3, and then it's going to be 4 pi over 3. So those are our two values. Those are our critical numbers. Critical numbers here. And go ahead and set up our number line just like before. So the good news is this one is locked in between 0 and 2 pi. I don't have to worry about all the multiples of these. So I literally I can sort of start it here at 0. I end it here at 2 pi, and then somewhere I've got my 2 pi over 3 and my 4 pi over 3. All right, so increasing, decreasing test. I want to know when my derivative, this is a number line for my derivative, is positive or negative. So between 0 and 2 pi over 3. So like pi over 2. So at pi over 2, if I'm looking at my derivative here, right, and I'm just trying to figure out the sign. So at pi over 2, the cosine is 0. That's positive, so I'm positive. Okay, between 2 pi over 3 and 4 pi over 3, so we can pick, pi. That would be an easy one to pick. Cosine pi is -1. 1 minus 2 is negative, so that means I know I'm decreasing here. So increasing, decreasing, which means what happens at 2 pi over 3? You're going to have a local max, right? Let's keep going though. So at 4 pi over 3 to 2 pi, so pick something like 3 pi over 2. So 3 pi over 2, cosine is 0 again, so that's going to be +1, so just positive, and then I can just stop. So again, my function is increasing on, I started at 0, so I can actually include 0. 0 to 2 pi over 3. 2 pi over 3. And cutting myself off there, and 4 pi over 3 to 2 pi. Okay, because, and the easiest way to probably just say it is simply because f prime is greater than 0, which is essentially using our increasing, decreasing test. F of x is decreasing on 2 pi over 3 to 4 pi over 3 because f prime of x is less than 0. So we've just determined increasing and decreasing based on our first derivative here using the increasing, decreasing test. Again, you don't have to call it that, I'm just saying. So this also tells us where our local maxes and mins might be by looking at where our critical number is and looking and seeing if f prime actually changes sign. Okay, f prime changes sign from plus to minus here at 2 pi over 3. So f of x has a local max, right? Because my slope is going from a positive to a negative. So it's basically a bump, facing down, so a bump at the top. So a positive slope to negative slope, I have a local max at, and this is 2 pi over 3. And where is the actual max? Like, what is the max value? So that's where it's going to be. What is the max? I got to go back to my original and plug that in. Oh boy. So it's going to be 2 pi over 3 plus 2 times the sine of 2 pi over 3. So the sine of 2 pi over 3 is going to be positive radical 3 over 2 times 2. So that's plus the square root of 3, whatever that is. Okay, I'm not using my calculator for this one, so I don't need a decimal approximation, but that's how you'd figure it out. And we have a max there because, and this is our first derivative test, f prime changes from positive to negative. Said another way, f of x has a local max at 2 pi over 3, comma 2 pi over 3 plus rad 3, because f changes from increasing to decreasing. They're equivalent statements. Okay, I just happen to choose using the f prime notation instead. You just have to word it correctly. You're not going to say f changes from positive to negative, right? And you're not going to say f prime changes from increasing to decreasing. They're on like different levels, right? You've got your position function or your original, then you've got your derivative, then you've got your acceleration or your second derivative, right? So just realize what layer you're on when you go to answer these. And similarly, f of x is going to have a local min at, and that's going to be here because my derivative changed from negative to positive. So 4 pi over 3, comma 4 pi over 3 plus 2 sine of 4 pi over 3. Well, sine of 4 pi over 3 is negative radical 3 over 2, so this is going to be negative radical 3. So minus the square root of 3. So it's very similar. And then because f prime changes from this one is negative to positive. And there's another example using the first derivative, finding our critical numbers, using our number line technique, and then essentially a combination of increasing, decreasing test and first derivative test to determine literally increasing or decreasing as well as where our maxes and mins might be. Okay? It's another good one for you, especially with the trig. Hopefully that helps. If you need anything, be sure and let me know.